Welcome to all. Class number 92 of our course. Right now, practice questions are going on for combinations. See, last class, uniformly varying load, I considered this way. I changed it now. But still, zero shear force point will be somewhere in the UDL. This is 92. 93 and 94, I will see that it will come under the point load. That is the easiest question. Further, since it is a practice question, as I told, see what I told last time earlier classes, I can give only question with the answer. But still, for those who find difficulty to get some values, I will briefly explain. Means something I will write. See, I made some ready here, but I have not done any numerical calculation. Okay, I will start now. As usual, important steps I will write. While finding reaction, moment about A, I will write here sigma m about A0. See, you have to write one more sketch, write VA, VB, all that you know it. So, minus VB into 12.5 anti-clockwise plus that point load 60 into 3 plus UDL 16 kilonewton per meter for 7 meter multiplied by 7 means half of 7 plus 30 into 7 plus moment of this uniformly varying load plus half into 3 into 12 is the total load. It will pass here means see this side. So 3 plus 4 7. This gap required you can calculate from 12.5 subtract all these values you will get 1 meter. So you can do one thing, you can enter here 1 meter. It is not given calculated value. So I told half into 3 into 12 total load into 3 plus 4 7 plus 1 8 8 3 plus 4 7 plus 1 8 8 plus 1/3 of 3 into 8 plus 1/3 of 3 lastly plus 40 into from 12.5 subtract 1.5 11 equal to 0 you get the value of VB. Okay, how much VB I'll write there. Okay, then sigma V0 I will not explain. Okay, plus VA plus VB minus 60 minus 16 into 7 minus 30 minus half into 3 into 12 minus 40 equal to 0 you get the value of VA. Make a neat entry here. Okay, I'll calculate in front of you only. That is 16 into 7 into 3.5 plus 60 into 3 plus 30 into 7 plus 136. 18 is the total load. 18 into 8 plus another 1 meter plus 40 into 11 divided by 12.5. 110.72 kilonewton. 110.72 kilonewton is VB. Then minus 40 minus 18 minus 30 minus 60 minus 16 into 7. That's all. Yes. 149.28 kilonewton. If anything is for skipped, you can make out later when I draw shear force diagram. Diagram will not close. Okay. Now, draw shear force diagram. Don't see there. Go up by, that is 110. See. Go up by 149.28. From here to here, linear, gradually come down by 16 into 3. So what you have to do? Into minus 1. Minus 16 into 3. It will give you 101.28. See, 149.70 around somewhere here. Somewhat scale. It is 101.28. Come down by 60. Minus 60. 41.28. Maybe somewhere here. 41.28. From here to here, down by 16 into 4, minus 16 into 4, 22.72. That is half of that value. Okay, somewhere here, reasonable. See, half of that value, 22.72. I'll write somewhere here now. Later, some space required for me. I'll write how much it is, 22.72. I'll write later. Come down by 30, minus 30. 52.72, little more than 41. Okay, how much it is? 52.72. This is, I'll write here now, 22.72. Okay. Then, from here to here, no load, go parallel to baseline. From here to here, come down by half into 3 into 12 and see that here maximum slope, here zero slope. Last time UVL was this way. See, we came down how? This way we came down, zero slope here. Now, it is not that way. It is this way. Here maximum slope. So, what will happen here? See, sorry. Last time it was this way. So, okay, actually you are below the baseline, I think. See, after here, zero slope here. So, therefore, how? We came down this way, zero slope here. But this time, here slope is maximum, here slope is 0. So, you have to come down by not how last time you came down by this way. Now, you came down by this, come down this way. When you reach here, 52.72, how much minus? Minus half into 3 into 12 is 18. 70.72 somewhere here. Okay, reasonably okay. 70.72 I write here later because space problem is there. But see, slope is maximum here, slope is 0 here. 0 slope, see. Okay, then 70.72, come down by 40, 110.72, that is 149, okay, reasonably okay. 110.72, and then no load here, go back up by 110.72, positive, negative, this value is 70.72, I will enter here, okay. Now, after drawing, those who want, show the calculation, shear force at A, just to left of C, just to right of C, just to left of D, just to right of D, E, just to left of F, just to right of F, and B. Many times explained. You show the calculation and get the answer. First of all, practice question. What I am telling is beyond the requirement for a practice question. Okay, now, next one calculation I will show here. Location of the point where shear force equal to 0. See, it will be after C, before D. See, somewhere here. I will call the take as X. If I take X, I will take X from here. This X equal to, you enter later, answer. That is the value of X. So, many options are there for you. Basic option, actually that also I told so many times. Basic option is, you write shear force here. Shear force at X, look this side. Actually, you can do one thing. When, see, just to right of C, we got shear force equal to 41.28. It is plus 41.28 minus 16 into X. 16 into X equal to 0. You get the value of X in meter. Or you can one thing, suppose you find difficulty, do one thing, start from there. Plus 149.28 minus 16 into 3 minus 60 minus 16 into X. Or you can do one thing, 149.28 minus 16 into 3 plus X minus 60. Whatever you want, you can do it. Or similar triangles. This also I should not tell for a engineering student. 41.28 by X. Similar triangles you can use only if it is linear variation. 41.28 divided by X equal to 22.72 divided by, this is 4 meter, 4 minus X. That way also you can get the value of X. Or, I told one more thing, mathematical concept class, I think class number 1. I uploaded that one. Directly, when linear variation is there, or directly X equal to, here, 41.28 divided by 41.28 plus 22.72 into the total length there is 4. That also will give the value of X. All these 3 X values will come same, my guarantee. That value you enter here. Okay, now BM calculation. See, as usual, I am not calculating X, but I will get the BM at X. Last time I told you, There's a trick there. I will explain the trick once again. But danger unless you understand correctly. Okay, leave it now. Start BM calculation. BM at A 0. I show the calculation here. BM at first BM at A 0. BM at C. Look this side. Plus 149.28 into 3 minus 16 into 3 into 3 by 2. You calculate. I will enter the value here. That will come 149.28 into 3 minus 16 into 3 into 3 by 2 will give you 375.84. Where I should write here. See, 375.84. Okay, reasonable space 375.84. Okay, then BM at D. Look this side. Plus 149.28. You calculate the value, answer is there. 149.28 into 7 minus 16 into 7 is the total UDL into 7 by 2. Then lastly, minus 60 into 4. Calculate. 149.28 into 7 minus 16 into 7 into 7 by 2 minus 60 into 4 is 412.96. 412.96. Little more. See. 412.96. Okay. Then BM at E. Look this side. Plus 110.72 into 4.5. There will be people who will ask, when you look this side, you took clockwise positive. You are looking this side. Again, you are taking anti-clockwise positive. No answer from me. How? Class number 92. So that is, if you, as I told you, my class is for those who follow each and every class and understand. By this time, if you follow all the classes and thoroughly work out, you would have been in a very high level. Then into 4.5 minus 40 into 3 also minus moment of this load half into 3 into 12 is the total load into, it is acting here from here 1/3 of 3. These all explained endless number of times. Calculate. Okay, I will calculate there. 110.72 into 4.5 minus 40 into 3 minus half into 3 into 12 into 1. That's all. Yes. 360.24. Anyway, I am not writing here only. I am not writing there. 360.24. Where? Here. Such a drop. Getting a little doubt actually. Okay, no problem. I'll check it. 360.24. Okay. 360.24 here. BM at F. Look this side. Plus 110.72. BM at F. 110.72 into 1.5. That's all. 10.72 into 1.5 is 166.08. 180. Okay. 166.08. Now, not over, we also require BM at the point X. One more thing I told. See, at E, when you look this side, triangle will come. Suppose you are afraid of triangle, look this side. 149.28 into 8 minus 16 into 7 into 1 plus half of 7 minus 60 into 5 minus 30 into 1. Same answer will come. And now lastly, BM at X. I'll put the calculator there. See. Look this side. Sorry. Oh, you have to calculate the value of X. But before that, I write the answer here. Sorry. Oh, see. Now, this is 4. If I write there, it will overlap here. 412.96. Okay. 412.96 I got here. Here I got 412.96. I want bending moment here. See, I will get the answer without locating x and without calculating anything. Those who are serious, you observe, see, trick, look this side. This shear force, left up is positive, so no problem. 41.28, square the shear force, divide by 2 and divide by intensity of load, 16. Then, whatever you get, add the previous bending moment, 375.84, 429.0912. 429.0912. Little more, see. 429.0912. Or if you look this side, this shear force is negative, but no, even if it is negative, right side up is negative, so you should take plus only. 22.73, say anyway when you are squaring, there is no effect. 22.72 square, divide by 2 and divide by how much? 16. Then add whatever BM you got here, plus 412.96, 429.0912. This is a perfect check for me. This trick actually, I only developed it, but it is not a crude method. It has got a perfect justification. This I will tell later when I go for all shortcuts and tricks for SFD BMD meant for competitive examination. Not only SFD BMD, almost each and every chapter of structural engineering. That is, structural engineering means engineering mechanics, strength of materials, structural analysis, theory of structures, matrix method, or RCC, or steel, or precious concrete. Wherever you go, I can give plenty of shortcuts. So many questions, people who may take around 10-15 minutes to solve. Sometimes, if it is possible for me to convince you, not for me, I can tell how to solve in just half minute or 1 minute. Wait, for some time is there. Okay, now I want the x value, correct? To show the calculation, I want x value. Now I am finding x value. Okay, one place I will calculate. 2.58 meter. I am not going to calculate here. I am writing 2.58 meter. Not calculating 2.58 meter. Okay, now calculate bending moment here. Bending moment here. Look this side. Plus 149.28 into 3 plus, enter the x value here, 2.58 meter. Okay, now, so plus 149.28 into 3 plus 2, 5.58 plus 149.28 into, I am using red color because where this red value is coming, so 5.28 minus UDL 16 into this length, how much? Once again same 5.28, 16 into 5.28 sorry, multiplied by, why unnecessary waste time, 5.28 by 2, lastly minus 60 into 2.58. I am not bothered to calculate it. It will come plus 429.0912. Guaranteed it will come kilonewton meter. That can be black color. Okay. Now go back and draw bending moment diagram. Okay. Now bending moment diagram. I already joined here. See, A to C second degree parabola. If I want to write here now, just to understand, parabola of second degree, actually not here. You have to write all those somewhere there. You know earlier problems. After I finish all the BM calculation, there you write all these things. Here, just mark parabola, that's all. Okay, now, C to D. See this full, from C up to D, single curve, and that red color is single curve. This full will be parabola of second degree only. Why? UDL. Then D to E will be linear. E to F, uniformly varying load. Therefore, this will be parabola of third degree. So I forgot right here. See, this will be parabola of second degree. Why? SFD BMD. And lastly, this is linear. Now see, here either side different shear force. See here. So this side slope is more, that side slope is lesser. Here also same thing. This side slope is lesser, 22.72. That side slope is more. And here, if I draw tan, see actually, if I continue this line, this linear, it should be tangent to this one. Because why? Either side same slope. Here, this side slope is lesser, 70.72. That side slope is more. Here, linear, 110. See, here 110.72. Here, high slope, 149.28. Okay, now BMD is drawn, everything is over. Practice thoroughly, get all the values, get more and more knowledge, learn this SFD BMD concepts, and each and every question practice thoroughly. Okay, now we'll meet in class number 93. 93 and 94 will be two simple cases where shearing force diagram will cross the baseline under a point load. Some will ask, how you know it? I will set the question. For me, not a problem. I will set the question so that it will come under a point load. Okay, then most important, I will go for couples. Okay, thank you. See you in class number 93.